Hi everybody, and welcome to the first C++ video of the semester. So in this video, I'll give you an introduction to numeric data types and arithmetic, and it will build on what we did in class on the first day. And let me just say before I do anything else that this video will be much like every other video in the course in that I will give information to you in slides, so in a PowerPoint type setup, but I will be switching back and forth between the slides and the compiler so that I can actually run some code and show you how the code works. So hopefully that's not too obnoxious to you to switch back and forth, but in pretty much every video I will switch back and forth between information and slides and demonstrating that information through the code inside the compiler. Let me also say that getting to this screen right here to where you can actually type code inside of Eclipse, that information is covered in like a prelude video or something, video 0 for the course. So that's a separate video that you can watch to get yourself here to where you can just type code and run it. Okay, so let me just start by recalling what we did in class on the first day, which is that you now know how to make the computer tell you things, how to make the computer speak English at you like this. So if you need some encouragement for your day, right, you can have the computer tell you this sentence, and the way you do it is with a cout command, and then these two less than symbols are like pushing the text to the screen. You then say what you want to say inside of quotes, and you close the command with a semicolon. So in C++, you always need a semicolon to close out a command. So, just to recall what we already know, let me type that. Okay, so there we go. And if I run this, takes a little bit, but there you go. You are so handsome, it told me, right? So that's the output of the program. Okay, so we already knew this. So suppose you want to do more. You want to write a program that has some interaction with the user. So it doesn't just say things. The user tells the computer things, and then maybe the computer does things with the data the user gave it. So here's an example of such a thing. Suppose you want to write a program that lets a user tell the computer the side length of a square, and what the computer does is it gives back to the user the area of the square to the screen. Okay, fairly straightforward idea, right? The user hands the computer a number. The computer basically just squares that number, right? And then gives you that result back. So what would a program like that look like? Well, the user enters a side length L, right? The computer asks the user, hey, what's your side length? The computer then calculates L times L, right, the area of a square, and prints the result to the screen using a cout statement. So the question in this video really is, how does the user give that side length to the computer? How do you actually tell the computer things? And then how does the computer do things with that data you just gave it? So here's how it works. The computer needs to create a storage space for that length. So if you want to hand it a length of 7, the computer inside of its memory somewhere, right, actually like a place in memory, has to create a storage space. And that storage space is called a variable. So the variable is where the number 7 or the number 13 or whatever the side length is, that's where that side length gets stored. The process of creating a variable, so the process of creating a storage space, is called declaring the variable. And variables come in all sorts of types. So you could create a storage space for a whole number. You could create a storage space for a decimal. You could create a storage space for English, type string, whatever, right? There are lots of different kinds of data you might want to hand to a computer. And so before you hand the computer your data, you need to decide what kind of data is it. And then you tell the computer to create the corresponding kind of storage space. So if in this program here, you are anticipating the user handing you a whole number, so like 7 or 14 or whatever, you would create a variable of type integer. right? Type integer means whole number. So you are telling the computer, hey, I'm expecting a whole number here, so please create a place in memory for a whole number. So a variable is like a box in which you want to store something. Just like in reality, if you want to store something, you first need to decide what kind of box is appropriate, right? So you don't try to store round things in a small rectangular box or something, right? You don't store one small thing in one gigantic box, right? If you're just going to put one small thing inside of a box, you choose a small box, etc., right? The analogy breaks down eventually, but you see what I'm saying. So for now, we will focus on two types of variables. Variables designed to store whole numbers, type integer or type long, and variables designed to store decimals, type float or type double. So type int for integer is used to store whole numbers, either positive or negative, that aren't too big. 7, negative 15,000. Long, what you're doing is you're telling the computer, hey, I'm expecting a really big whole number. So I'm expecting a lot of digits. So something like this, you would not store in an integer variable because the computer has not created enough memory for int to store that. You have to tell the computer, I'm expecting something really big. A float is used to store decimals without too many digits. So it's like the decimal version of int. And then double is like the decimal version of long. It's used to store decimals with lots of digits. So if you tell the computer float, I'm not expecting too much information, right? You would use double if you really want pi, for example, very precisely, right? There's pi with like 15 decimal places. So in class, when I used to teach this material face-to-face, the students would often ask me, well, double, it's kind of a generalization of all these other three. So integers, for example, are decimals, aren't they? Like 7, you can think of as 7.0 if you want. And, whatever this is, 100 million, that really is 100 million.0. And floats, of course, are also doubles. Floats are just small doubles. So the question is, why not just use double all of the time if everything is a double? And the reason is because if you create something of type double, the computer sets aside a lot of storage space for that to store all of these decimal places. So if all you are doing is expecting 7s or 13s or something, if you use double, you're just killing your memory, right? You're taking up too much space. It's like putting a tiny package inside of a humongous box, right? It's not efficient. And if you do it too many times, you're going to make your program extremely inefficient. The computer or the program will run more slowly. Okay, so arithmetic. So in C++, you can add, subtract, multiply, and all sorts of other things that we will do some other time, next time. The obnoxious thing about multiplication is that you must use the star symbol. So for example, when you write 2x in calculus or algebra or something, you really do mean 2 times x. The computer will not recognize what this means. The computer has no room for ambiguity. The computer, you must tell it, oh yes, 2 times x. So prepare to be annoyed by that at some point. Okay, so now let's actually write the program. So this program is supposed to have the user give you a side length, and then you do something with the side length. So let's just say for now we expect that the user will give us an integer side length. We're expecting the user to give us a 7 or a 20 or something. For whatever reason, that's what we expect. Okay. How do you get that side length from a user? Well, first of all, you could type them a message like, hey, give me your side length. Right, that seems like a reasonable thing to say to them. But once we've told them that, how do we get it? And the answer is, okay, so C out is pushing to the screen. It's the computer pushing text to the screen. C in is the command that brings things from the screen. So you reverse the arrows, and the visual here is supposed to be pulling from the screen. So what you're going to do is you're going to pull from the user a side length. So the user will type a 10 or something and then hit enter. That 10 has now entered the storage space you just created. Okay, so one thing real quick here. Suppose I take this out. What's happening here, you can see it's already yelling at me here. Before you ever use a variable, you have to create it. Okay, so you have to declare it. So that's what I did at the beginning. I declared side length, and notice it quit yelling at me right here. So this command right here is saying pull a number from the screen and put it inside of this box you created. But oh, if you never created a box in the first place, the computer doesn't know what to do with this, right? It has no idea what you're saying right here. So the way this program is flowing so far is that I've created a storage space for the side length, and then right here I'm going to take the number created by the user, and I'm going to put that number in this box. So for example, right here I could say, hey, like, tell me what that side length is. So this isn't the full program yet, but let me just run this and let's see what it does. Give me your side length. Side length 10. And then notice it prints 10. Right? So it knew that I put 10 into this box. That happened right here. As soon as I hit enter, the value of side length became 10. So a box that used to be empty was no longer empty. It now had the number 10 placed inside of it. Okay, so given a side length, we were supposed to compute area. So let me just create a storage space for area. Right after we get the side length, oops, let's just now say that area, well, what is area supposed to be? It's supposed to be side length times itself, isn't it? So notice the multiplication symbol, right? Okay, so now at the end of this, I can say something like this. Your area is, and now we can tell it what the value of area is. Okay, so let's just walk through what this program is doing. I start by creating two storage spaces, one for a side length given by a user, and the other storage space for the area of the corresponding square. Then we prompt the user to give us a side length. The user gives that to us, and what we then do is we place that value inside of this box right here. Inside of this new box, we place side length times itself. So if side length were 10, then area is now 10 times 10, and that's what it is. And then at the end, we can print to the screen area. So that's the idea of this program. There's one subtlety here, which is that whenever you have quote stuff inside of a cout statement and then non-quote stuff, so this area is not in quotes, it is not text, it is a numeric variable, so it has like a 100 in it. You have to separate things like that. Okay, so again, that's what I had a second ago. And notice there's a little yelling thing over here, right? The computer does not like that. So whenever you have a cout statement with text followed by variable stuff, you just have to separate it with a little double arrow. Okay, so let's watch this run. So give me your side length. How about 10? Your area is 100. And notice the formatting there is not very nice, so let me just put a space right there. Okay, give me your side length. How about 12? Your area is 144. Okay, so it works, right? So a couple of things before we leave this example. First of all, notice I declared my variables at the top. That's a stylistic thing. So for example, I didn't use area until right here. So you could have done this. You could have created area right here and then used it. There's nothing wrong with that code. Like the code will run the exact same way. It's just considered stylistically better. Like if a reader is going to come along and try to look at your code, a reader like me, right, when I grade your work, it's better to have all the variables grouped up top so I know exactly what to expect to see later on. Notice I also, you can name these things whatever you want. I gave them names. You can name them anything. So instead of side length, I could have named this like X and Y, and then everything works the same as long as I relabel X, 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 Y, Y. Okay, this will run the same way because you have complete freedom to name these things whatever you want, essentially. There are a couple of exceptions, but we'll get into those later. So now give me your side length, 10, your area is 100, right? the computer doesn't really care what you call these things. The reason I called them something suggestive, like that, is so that it's easier for another user to come along and read this, right? Like when I call that side length and I call that area, it's pretty clear what I'm doing here. Okay, so let me just finish with one more example. Suppose that instead of doing area of a square, we want to do area of a rectangle. Well, with the area of a rectangle, of course, you don't just need to know one side length. You have to know a length and a width. So now let's create two separate storage spaces, one for the length of the rectangle and one for the width. And then we'll still have an area. And let's say this time, I don't know, maybe the user is going to give you decimals. So maybe the length could be 3.7 and the width could be 3.8. Okay, let me clear all this out since it's yelling. Okay, notice a couple of things about this. First of all, if the length is a decimal and the width is a decimal, there's no reason to think the area will be a whole number, right? Because decimal times decimal is in general a decimal. So sometimes, depending on what the storage space is, if you're going to use it some other time, you need to make sure that you respect what kind of data type you're expecting. So if area is eventually going to be length times width, and length and width are decimals, you have to respect that. Okay, so let's just write this exactly as we did before. So we'll prompt them, like give me your length, and give me your width. Okay, so now we've grabbed two different variables from the user. And now we can say the area is length times width. And now we can say area is, and then we're done. So let's run this and see that it does what we think. Okay, so my length maybe will be 10 and my width will be 20. Area is 200, right? It formed length times width. Okay, so to conclude this video, now you know how to create storage spaces for data that the user will give with consideration of what kind of data the user will give. Let me just give one specific comment before we wrap up and then we'll be done. Notice I write here area equals length times width. So those of you who have had any sort of algebra experience at all, right, you know that equations are symmetric. Like if x equals y, then y equals x, right? I mean, you can switch the sides of an equal sign. Notice that it's not quite the case in C++. Notice it's yelling at me here, okay? So this actually isn't really like an algebraic equals right here. This is what's called an assignment equals. So what you're doing is you're saying, hey, this stuff over here, put that inside the box area. And so the area has to be on the left. Whatever's on the right gets placed in what's on the left. That's why the computer has no idea what's happening here. It's expecting a single variable on the left, and then you put other stuff on the right. Okay, so now it's happy with me again. Okay, so that concludes this video.